Hi there, ninth graders. This is Dr. Welch, your grade level leader. I was sitting with Miss Herbert. She said, you know what, could you show the kids just maybe a couple of different ways of looking at these equations and these practice questions? And I said, sure, no problem. So here we go. So looking at your formulas here, what you'll notice is you have speed, which you'll see is the change in distance over the change in time. So over here, what you'll see is the speed. We have the formula, the average speed is equal to delta S over delta T. So remember that that delta actually means something. So as you can see down here at the bottom, delta, the triangle, means final minus initial. So when it's delta S, it's the final distance minus the initial distance divided by the final time minus the initial time. Here with velocity, as you have learned, velocity is a vector quantity, so it has to have a magnitude and a direction. So that's the final displacement minus the initial displacement divided by the final time minus the initial time. Acceleration is also a vector quantity, so I have the change in velocity over the change in time. So final velocity minus initial velocity divided by final time divided by initial time. Now, you have some nice steps here that have been given in terms of following and solving formulas and equations. But what I would like to do is to show you another way that we do this in physics. And one of these is looking at this question here. So if you look at question number 1 here, I want you to listen to me read the question. What did you hear me say? Exactly. I didn't even read the question. What I did is I just looked for numbers and I highlighted them. Now I'm going to reread the question. It says, Usain Bolt holds the 100-meter world record with a time of 9.58 seconds. What was his average speed during his 100-meter sprint? So when you get these word questions, whether it's in math or science, you want to kind of get organized. So getting organized, you want to write down what you know. So I know that Usain Bolt ran a distance of 100 meters, and he did that in a time of 9.58 seconds. So what I'm looking for here is what is his average speed? So that's my unknown over here. The second thing you want to do is actually check your SI units. Is distance measured in meters? Yes. Is time measured in seconds? Yes. So when you do this, this actually saves you a step because that means that when you do the calculations, your final answer will automatically come out in the correct SI units. And so when we get over here, we then find the correct formula. So we see the correct formula here is change in distance over the change in time. So we have 100 divided by 9.58. And when we calculate that, what we wind up getting is a value of essentially 10.1 or 10.1 meters per second. So that's a scalar quantity, so we don't care about the direction. That just gives us the average speed in which Usain Bolt ran. Next question here, same thing. I would just look at the question, look for numbers. So I've highlighted negative 5 meters per second squared in 5 seconds. So that's what I know here, that the acceleration is negative 5 meters per second squared. The time is 5 seconds. What is unknown here is actually what is the change in velocity of the car. So this can typically be confusing for students. You're not looking for final velocity or the initial velocity, you're looking for the change in velocity. So I then go through my steps. I check to see if the SI units are correct. So acceleration and time are in the correct units. So that means that when I calculate the change in velocity, it will also be in the correct unit. So I find my formula, plug in the values, and then multiply and divide. And what I get here is I get negative 25 meters per second for the change in velocity. So what this negative sign indicates, it actually tells you the direction in which the velocity is actually going. So that would be, and see how the, over here, acceleration is negative. And you see that this value is negative, so that just tells you that the change in velocity is in the same direction as this acceleration. Scrolling down here, we get into this next question. I've highlighted the numbers and I read through it. I see that I know the speed is 10 meters per second. The distance, is 500 meters. They're both in the correct SI unit, so when I solve for this, I'll get an answer in the correct SI unit also. So I just plug in the values to the correct formula, then solve, I get 50 seconds. This next question here is worded kind of weirdly, but I think when this question was written, they were just hoping that you would pay attention to the words starting and final and just plug it into the formula. So once again, I know the initial displacement, the final displacement, and I know the time. All are in the correct SI unit. So when I solve for velocity, I'll get the correct SI unit also. So I just plug the values in. I get negative 700 over 140, which gives me negative 5 meters per second. Or you could say it's 5 meters per second, 5 meters per second in the opposite direction. Now, if you're trying to visualize this, it's a bit tricky. So this positive 500 that you see up here just indicates that you're 500 meters from the starting position right here. And this starting position is a reference point. So you're starting here, but your reference point for that positive 500 meters is here. And so then ultimately what you wind up being is negative 200 meters from that reference point. And so the total distance you would travel from start to the end here is negative 500 plus another negative 200, which is a total of negative 700. So kind of a weird one to visualize there, but that's how you would figure out that displacement. Now, with unit conversions, I'd like to show you something that's going to be very helpful with both chemistry and physics going forward. And so what I'm going to introduce you to here is something known as a conversion table. So before we start with the conversion table, I'd like to show you a kind of a math problem here that you'll see down here in the notes here momentarily, but I'll write it a little bit differently. What if I had this equation here, and it was given to you in your math class? You know some things about this equation. One thing that you know here is that this part of this fraction is known as the numerator. And we know down here where we have the y, this would be our denominator. And the other thing that we know here is in the middle, we have this horizontal line. And as you may remember from your math class, that horizontal line just means you divide by. And so if your math teacher gave you this problem and asked you to simplify it, you would realize that the y's cancel out, and what you ultimately have here at the end for your answer is 4x. If you're familiar with this from your math class, you can actually use the same exact strategy when doing conversions with conversion tables. And so, for example, what you will notice down here is I've given that same example over here that I gave above, except I just used 2xy instead of 4xy. And what you'll notice here is that I have written down some information. So in this question up here, we have 328 kilometers per hour. So this information that you see here is the given information, which I've written here. So 328 kilometers per hour. So that per just means that you're dividing by that value. So 328 kilometers per hour, 328 kilometers for every hour. So what you wind up doing is you just write down the given information. Here I have 328 kilometers per hour. Now the next thing you want to do is you want to try to cancel out these values. And so with these next two columns that you see here, what you're essentially doing is you're setting up equalities. And so if you try to cancel out the kilometer first, what you have to ask yourself is, what do you know about a kilometer? Well, what you know about a kilometer, hopefully, is that 1 kilometer is equal to 1,000 meters. So notice how kilometers is here in the numerator. So you'd have to put kilometers here in the denominator to cancel it out, which is what we see right here. The unit of kilometers cancels out, and 1,000 meters goes up here in the numerator. And so when you do that, what you wind up having is 1,000 meters times 328 divided by 1 hour. But we want it not in meters per hour, we want it meters per second. So notice how hours is here in the denominator, and what we know about 1 hour is 1 hour is equal to 3,600 seconds. If you didn't know that, then 1 hour is 60 minutes, Each minute has 60 seconds. 60 times 60 is 3,600. So since 1 hour is here in the denominator, we have to put hours here in the numerator to cancel out, because hour and hour cancel out. And then 3,600 seconds is in the denominator. So what we ultimately have here when we cancel out everything is we have 328 times 1,000 meters times 1 divided by 3,600 seconds, which gives us 91.1 meters per second. You can see the same thing in the next question here with the student running 5 kilometers in every 52 minutes. So the given information is 5 kilometers for every 52 minutes. Then we do the equalities once again. So we have kilometers in our numerator. So 1 kilometer in the denominator is equal to 1,000 meters. The kilometers have canceled out. We have minutes here in the denominator. So 1 minute goes in the numerator. 1 minute is equivalent to 60 seconds. So you multiply 5 times 1,000 divided by 52 times 60, and you get 1.6 meters per second. The next one here, you could use a conversion table, but it's actually with this one a little bit easier to do the conversion itself. So if you think about rest would be at 0 meters per second. Final velocity is 25 meters per second, which is the correct SI unit for velocity. This one here is the wrong unit for time. So you have to convert minutes to seconds. So 12 minutes is equal to 12 times 60 seconds, which is 720 seconds. Now, once you have the correct SI unit here, you then plug in all your values, which are also in the correct SI unit, and you'll wind up getting the correct value in terms of the units when you do the division here, and you get 0.035 meters per second squared. Now, technically, acceleration is a vector quantity, so you need to give it a direction. So we don't know which direction it's going. We don't know if it's going northeast, south, or west, or in the positive x, negative x, or left or right. So one way that we can get around this is by just saying that it's moving in the direction of motion. Now, these optional exercises I do not have access to here, but hopefully this is helpful for you, and wish you guys all the best with your physics units. And if for some reason you have some questions, you can always drop by room 3205 and ask a question or two. Always happy to chat. All right, take care, grade 9.